Today we're going to talk about solving quadratic equations and continue that process. So far we have solved them by graphing, which is not a bad method if those x-intercepts come out perfectly. Factoring, which you can only do some of the time. And in concepts, we've talked about completing the square, which we're only going to do when a is 1 and b is even. And in Algebra 2, we'll be talking about that early next week. But today we're going to learn about the quadratic formula. So this formula can be used to solve any quadratic equation, keyword any quadratic equation, once written in the form of ax squared plus bx plus c is equal to 0. So the key there is you need to make sure that you get it to equal 0 first. The solutions then are x equals negative b, which means the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, this part that is underneath the square root sign, the b squared minus 4ac part, is called the discriminant. The discriminant, very powerful part of this. Because to solve a quadratic using the formula, the first thing you're going to do is find that discriminant. And that's going to tell you a lot about the equation. If that is a perfect square, so if that's a number like 4 or 9 or 25, that means you could factor the problem. It also means you would have two rational roots, which means they could be written as fractions. If the discriminant, this b squared minus 4ac part, is greater than 0, which means if it's positive, you're going to have two roots. And if it's not a perfect square, they will be irrational roots, which means they would involve a square root of a number that's not a perfect square. If the discriminant equals 0, you're going to have one root. And if the discriminant is less than 0 or negative, you would have two complex roots, which remember will involve I. Once you find the discriminant, you'll complete using the rest of the formula. So this part has been done already for you. That would be the discriminant. And then here you just have the opposite of b, negative b, and then it's all over 2 times the a value. Then, if that part under the square root sign can be simplified, you should do that. So, a couple examples. You might want to have your calculator ready. So for this one, this is in the form of ax squared plus bx plus c. So the first thing I'm going to do is my discriminant, which is b squared, that would be 25, minus 4 times the a, which is 2, times the c, which is 3. So if I do this on my calculator or mentally, I get it to be 1. So 1 is my discriminant. That tells me that 1's a perfect square. I could factor it if I want to, and they're going to be rational roots. All right, so then the rest of this formula, now I have the square root of 1 here. The part that goes out in front is negative b, which would be a negative 5. And on the bottom is 2 times a, which would be 4. Now, as far as simplifying goes, I know the square root of 1 is 1. And so now I'd have negative 5 plus 1, which is a negative 4, divided by 4 would be a negative 1. And then negative 5 minus 1 is a negative 6, divided by 4 would be a negative 6/4, or a negative 3/2 when I reduce that. All right, this next one, it's ax squared plus bx plus c equals 0. That's good. The a value is 1. The b is negative 7, and the c is 6. So my discriminant's going to be b squared, so 49, should always be positive, minus 4 times 1 times c. So it's 49 minus 24, which is 25. Again, that's a perfect square. Tells me that I could factor this. But using the formula, I already have the square root of 25 complete. I just need the negative b part, which would be a positive 7 in this case, and the 2 times a would be 2. I know that square root of 25 is 5. So now I've got 7 plus 5, which is 12. 12 divided by 2 is 6. 7 minus 5 is 2. 2 divided by 2 is 1. And those would be my two solutions. This next one you can see does not equal 0, so I need to get it to equal 0. I'm going to subtract 7x. I'm going to write it in that form. And then I'm going to find my discriminant. So I'm going to have b squared, which would be 49, minus 4 times the a times the c equals 0. And then you got a double negative in here. If you do this on your calculator, or those are going to turn to positive. 4 times 2 is 8 times 4 is 32. So it's 49 plus 32, which is 81. That is a perfect square. I could factor this again, but using the rest of the formula, I'd have a positive 7 plus or minus the square root of 81 all over 4. That's 7 plus or minus 9 over 4. 16 over 4 is 4. And then a negative 2 over 4 would be a negative 1/2. And those would be my two solutions. All right, just going to give you another example. Something that may not come out to be a perfect square. So let's say I've got 3x squared minus 2x minus 5 is equal to 0. All right, so finding that discriminant, it would be 4 minus 4 times 3 times a negative 5. I just realized that's going to also be a perfect square. That would be a positive 64. Let's change this a little bit. And let's make this a positive 4. So now if I find my discriminant, it would be 4 minus 4 times 3 times 4, which is 4 minus 48, which is a negative 44. Now that is not a perfect square. So now we're going to continue doing the rest of it. The negative b part is a positive 2. The a value, 2 times 3 would be 6. And then all I would need to do is simplify this like we did the last couple days in class. So remember, I can break this up into root 4, root 11, and root negative 1, which would then be 2 plus or minus 2 root 11i all over 6. Now you can see you can take a 2 out of all of this. And if you do, you would end up with this. And you could leave your answer just like that. There are two complex roots, so this parabola would never cross the x-axis. All right, I've got 3 problems for you to do in Google Classroom. Hopefully you can work through those and submit a few of those right away this morning and today. Have a great day. You can always check back with me on Google Meet during the video and during this time.